So good afternoon. So I'd like to talk about our research activities to enhance the security or maturing the technology of blockchain and its ecosystem. Okay, so this slide shows that I think that the ordinary style of the maturing technologies experiment in the laboratories is the first step. And if that the technology is confirmed, and we can start the commercialization based on the technologies, and after that we can have that new application, the ecosystem based on the technology. This is an existing style of maturing technology. But so my question is, so what is the current status of the blockchain technologies? So we have that 1,000 participants consensus event last week, and we have that tons of money already invested in this technology. But so the situation of the maturity of the technology is confused, and I think that the current status of this technology is only the blue or green stage. Okay, so in these several years we had several huge incidents in the security of blockchain. For example, Mt. Gox, or the DAO attacks and the CoinCheck incident this January in Japan. The last weeks we had another attacks on the blockchain itself, not the exchange, just the blockchain itself. This is selfish mining. This is a theoretical attacks we already know, but this kind of theoretical attack become realistic in the blockchain technologies, blockchain-based cryptocurrencies. We have several large incidents at this time. Okay, and there are many technological challenges to maturing the blockchain technology and cryptocurrencies. So first is regarding the cryptography and the cryptographic operations. So of course we need to operate the cryptographic keys securely by every person or every servers. And the other one is a secure system design and operation. This is a anti-cyber attacks and so on. And of course, we need to care about the trade-off between the performance, scalability, and how decentralized the blockchain is. Of course, from the financial point of view, so finality and immutability is another issue to deal to fit with the existing manner of the financial technology. And of course, additionally, so we need some kind of healthy community and ecosystem. You know that last year and before that, we had several divisions of the Bitcoin blockchain. This caused many complicated situations in the cryptocurrency. So we need to design the better incentive economical model. So game theory and incentives are important things for blockchain ecosystem. So the security of Bitcoin and the cryptocurrency is not based only on the cryptography and the computer science, but also game theory and incentive design is a core part of the security of the blockchain and the cryptocurrencies. But so as I told, there are some failure of the designing the Bitcoin blockchain incentive design. It causes so much flaw in the current operation and governance of the Bitcoin blockchain. And of course, after that several incidents and scams or something, so regulation is a hot topic at this time for Bitcoin and blockchain ecosystem. I would like to go back to the history of the internet technology development. The internet technology is commercialized in 1995. Before that, but as all of us know, that the original internet technology was development of the internet technology is started by ARPANET in 1969, and before the commercialization of the internet technology. So we have the 10 years period to maturing that technology. This was started in 1985, and this activity is called NSFNet. This is a test bed and the research network by international universities, and founded by NSF. And we had several nodes in many universities in the United States, and this testbed be a source of the commercialized internet. And in parallel, from 1977 to 1995, UC Berkeley operated Berkeley Software Distribution Project to maturing the code base of Unix. This is a source of the stabilized the internet operation. This kind of the testbed and bottom-up style, open source style development of software can be a good component to maturing the internet technology. This is a history. And this is the history of the BSD. So at first, 1969, AT&T Unix is the source of the BSD Unix, and it was bring to the UC Berkeley, and UC Berkeley collect many code bases from all over the world in the one place, and this is the source of the DEC or Sun OS Unix. And after the release of the 4.4 BSD Lite release 2, that technology, that project is over. But this is a good source of the next generation of the Unix and the development of Linux. And in the this slide shows that difference between the development of the internet technology and blockchain technology. In the case of the internet technology, the maturing steps of the technology is quite natural. At first, research by universities was happened, and so company implemented that code. And after that, we had so many steps of standardization by IETF and so on. After that, company started the business, and the BSD and open source facilitate that kind of innovation by the internet. But the case of Bitcoin and blockchain, the things are quite different from the case of the internet. So Satoshi Nakamoto, I don't know him, but Satoshi Nakamoto published a paper in 2008, and after that 2009, reference implementation was disclosed, and the company started that implementation of actual business right after that 2009. But at that case, standardization and the research by university was left, and we need to repeat that kind of steps to maturing the technology, same as the internet. So this is the reason why I started one project called BSafe.network. So this is a neutral, stable, and sustainable research test network by university, international university. And this project was founded in 2016, and each university has a node of blockchain and installs software, the same software for experiment. And the main area of research is not limited to security or network. We can do any kind of the research topics over this using this testnet. So the reason why we choose the university is a good place to do such kind of experiment. So first, this is a place for experiment by definition, and so all of us believe that universities is neutral place to discuss about the technology or something, and so this is a place of diversity. So most of all universities has a computer science division, legal division, or business school or something. You know that blockchain is not only the cryptography, but this is this consists of many kinds of background, including computer science, network, P2P, game theory, blah blah blah. Of course, and this is a good place for the international collaboration. If there's some R&D is organized by the private companies, it's not easy to form that international collaboration. And the number of universities all over the world is over 15,000. So that kind of activities can scale. So at this time, we already have the 27 universities which join that BSafe.network. University of Houston is one of the members of this initiative. And of course, we are now adding more. So I would like to explain several examples of the research over BSafe.network. The first is the sensor network and blockchain. So this is the name of project is SafeCast. This is an open science, student science project initiated by a Dutch guy live in Tokyo. This project was initiated after the Fukushima Daiichi power plant accident, after the huge earthquakes in Japan. At that time, that Dutch guys think that we need tons of data collection regarding the radio action. So that guys have created $300 bento box Geiger counters and circulate that Geiger counters throughout Japan and the other countries all over the world. And they collect so much information regarding the radiation data. And by using blockchain, we can give the provenance to the radiation data with time and location. And so if that kind of data is mashed up to another kind of logistic data, we can create some confidence to the moving of something. For example, if we record the movement of some vegetable or food or something, by mash-upping that with this kind of data, we can assure the how that fruits or something is polluted by radiation or something. This is also one of the use cases of the blockchain. The other is facilitated data fabrication. So this is also one subset of the trade finance of something. But we would like to apply the blockchain to 3D printing and digital fabrication. So when we create some product by using 3D printers, by coming from the one design data, we can assure that final product, provenance of final product and original data and something by using that blockchain. So when we create something by using the 3D printers, we attach an RFID tag to the product. And we can facilitate both trace and trading of product by Bitcoin or digital currency and blockchain. We can do all of the things, including provenance, certification, trading, or payment. And the final example is for the smart contract and the trade finance. So when we think about the smart contract, with thinking about the DAO issue, the designing of scripting language or program language is the important thing. For example, the universities can design the domain-specific languages. This is the aim of designing this kind of domain-specific language to limit the possible evaluation state, execution status, which includes insecure state. And this kind of activities can reduce the possibility of attacks. And this is suitable for formal analysis to reduce that bad design of specific languages. And this should be a good tool for communication with regulators. This is one kind of this figure shows that some model of the trade finance and letter of credit. And we can analyze the state transition in the use case of the letter of credit. This is some kind of a tiny example, and I think that reality is more complicated than this figure. But this kind of the analysis can facilitate to create more secure languages to securing the smart contract. Okay, I think that I would like to move to Paul Brigner to explain that our activities at Georgetown University.
Thank you.
Okay, move to.
Hello? Hey, there we go. Great. Thank you. It's great to be here today. So Professor Matsuo laid the foundation and gave a very good argument for why there's a need for academic research. As managing director of our research center, my job is to tell you how you can be involved. So that's where we're going to go with the direction for the next couple of minutes. And I know we're behind, so I'm going to try to go through it quickly. So Professor Matsuo outlined where we've been. If you look at the far right of the slide, it shows that we've had all sorts of experiments. There's been a lot of activity, but there's been gaps. There's been issues. And there's other consortiums that are working on these types of problems, but they're very broad. So we're proposing something different. What we need is a next step for multidisciplinary research. We want to focus on building an ecosystem for blockchain. And we're doing that through a very specific model of research that I'm going to describe. And the goal, of course, is to have an internet-like innovation platform and ecosystem. So the model that we have is established by the National Science Foundation. It's actually been in use and in practice for over 40 years. And at Georgetown, we have some experience with this model. It's called the Industry University Cooperative Research Center Program. Industry University Cooperative Research Center Program, or the IUCRC program. If you do a quick search for IUCRC and NSF, it'll take you right to the page where you can read all about it. But based on 40 years of experience, they have designed this model where you have affiliates. It can be industry, it can be government agencies who provide funding and research guidance to a group of universities who hire students, hire grad students. We have researchers already, of course. We have professors who are working on these issues. So we actually collaborate all together as a group of affiliates and a group of universities to work on the problems. The National Science Foundation oversees the whole program. We have to do regular reporting to the National Science Foundation. They provide a little bit of funding for administration, but really the funding to do the research is coming from affiliates. It's coming from industry and government. And there's opportunities for large and small companies. So one of the major benefits of this approach is that it's very cost effective. And one aspect of that is the National Science Foundation mandates overhead rates for university research. If you've ever had any experience with university research, you might know that the overhead rates that go to the university can be upwards of 50 to 60%. So the NSF sets a cap of 10% for this. So we have 90% of the money that is contributed that goes directly to research. And we're not looking for hundreds of thousands of dollars from any particular company. There's a set rate where you join at a fee for both large and small companies. So it's very affordable, very cost effective. And the intellectual property that's developed in the center is shared among all the affiliates. So it can be public sourced if you want, or we can keep it in the center and only the affiliates can benefit. So here are the goals of the BTED. And again, BTED is Blockchain Technology and Ecosystem Design Research Center. Professor Matsuo has gone through a lot of these already, indicating that we want to follow on the NSFNet and BSD models for the blockchain ecosystem. Of course, develop research and intellectual property for our affiliates, use a multidisciplinary approach, and then contribute to standardization. So we will be involved in all sorts of standardization activities through the center. The member universities, Georgetown, since we do have experience with our other research center, we are leading the effort, but University of Houston is joining with us. We have already been working with the NSF, the University of Houston, the University of Central Florida for a few months now, going through the NSF process, well on our way. to becoming a formal center, although we're already operating. So there's no need to wait to become engaged with us. You can already do that. And Professor Larry Shi at the University of Houston is the person to talk to if you'd like to join that particular site. Each site has its affiliates, but we all work together. You do have to pick a site to join. Examples of research projects. Again, I think Professor Matsuo touched on a number of these examples, so I'm not going to go through them in detail since we are running behind. Go ahead.
Going back to my part. Okay.
Yeah.
Okay.
Yeah.
So I would like to go back to the case of the internet technology. Okay. So this 2 or 3 years or more years, we have the tons of attacks to the TLS and SSL protocol. So TS 1.3, this is a newest version of the TS protocol. So we had a extensive joint work between the developer and open source community and academia. So in the process of the development of TS 1.3, so we have several conferences between that. So we gave that some result of formal verification of the protocol, and the final specification of TS 1.3 become more stronger. So this is a good model of the collaboration between the industry and academia. That we can add more trust to the specification. And originally, that blue portion of this figure shows that originally the developers of the Bitcoin blockchain think that so P2P cryptography, consensus business logic can create only this portion can create decentralized money. But so after that DAO attack, so we realized that so this is not the case. So with wide background of academia, including computer science, economics, law, and other kind of things, can help that healthy decentralized ecosystem. Academia is an essential part of diversity, and it makes a blockchain, Bitcoin ecosystem healthy. Thank you very much.